Right, so we're going to look at circular graphs here now, and as you can see, we've got a graph of a circle right here, and we can see that the radius is 3. Okay, it's centered around the origin. You can draw circular graphs that are not centered around the origin. I'm not sure that comes up in GCSE, and it's not going to be something I'm going to cover in these videos. But let's try to understand why is this graph. How can we come up with a formula for this graph of the circle? Well, what we'll do first of all, is we will imagine drawing a line from the center to any point. So let's just draw it to this point here. Let's draw it to actually that one there, because we can actually more easily read what the X and Y part. No, actually, no, I'll change my mind. Back to here. Okay, right. Now, that would be the radius, but also what I can do is I can draw a triangle. So if I go down like that, and then I go across to the origin, the length of this, let's say the base here, the length of this base we can see is 2. Okay, we'll just say 2 divisions, right? And the length of this height we can see is, well, it's 2.2, isn't it? There are 5 divisions between each number, so this is 2.2. Roughly, it might not quite be 2.2, but it's roughly 2.2. We can see that this is a right angle triangle, and so and the hypotenuse would actually be the radius of the circle. So using Pythagoras, we'd be able to say that the radius is going to be equal to the radius squared is going to be equal to 2 squared plus 2.2 squared. Okay. So this is rounding up. I'm sure that it's not exactly 2.2. In fact, I can pretty much guarantee it's not exactly 2.2 there, but it's roughly 2.2 by sight, isn't it? So if we were to rearrange this, we'd say that r is going to be equal to the square root of 2 squared plus 2.2 squared. You can pause the video if you like and see if you can work out what that is. And you should have found out that you end up with rounding up to two decimal places, 2.97, which is close to 3, right? As I said, that's probably not exactly 2.2. But also what I want you to notice is that this 2 here is nothing more than the x coordinates of this point here, right? So the coordinates of this point on the circle is going to be just 2 and 2.2. So the height is whatever the y coordinate is, and the base is whatever the x coordinate is. So in other words, the radius squared is going to be equal to any point on the circle, and it does work. It will work in the other 3 sectors as well, in the other 3 parts of the circle as well. It will always follow this formula. The reason why it works on the other places is because you'll have -2, for example, but -2 squared is the same as 2 squared. So whenever it's a negative, the squaring of it makes it treat it just like it's a positive anyway. So that is essentially the formula of a circle. So if I now get the graph, which I've got somewhere here, if I can just work out which tab it is on my other monitor. Here we go. And if I it's, as I said down here, r squared equals x squared plus y squared. So therefore the radius is 3, so 3 squared is 9. So x squared plus y squared equals 9. Okay, so that is how to do the an equation of a circle. So let's say that you wanted to draw a circle where the radius of the circle is 2, what would the equation be? Pause the video and we'll see if you can work out what it is. So hopefully you should have said it was x squared. By the way, on this thing, if you want to do a squared symbol or power to any power symbol, you do shift 6, which looks like a little arrow pointing up. So x squared plus y shift 6 and then 2 is equal to, and I said a radius of 2, so 2 squared would be 4. Okay, so that's how you do an equation of a circle. Okay, so we'll stop the video there and building up to now tangents.